statics man to. So today I will going to discuss to you about acceleration forces. So when we say acceleration forces, this is dynamic in nature. So we analyze objects in motion. So naglihok ni siya. And then of course, its velocity is not uniform. Okay, by the word itself, acceleration, so its velocity changes from time to time. So it has acceleration, and therefore, if ever we have acceleration, we also have net force. So again, why we have net force? Because acceleration and the amount of force being applied on an object is related to each other by the formula of Newton. F is equals to mass times acceleration. So namin sila yung relationship sa sakusa. And then in analyzing acceleration force ng mga problems, let's say if we have here an object, maring ni sa class pwede kanang maglibog. So if you have an object here, then siya naka-rest or naka-constrain siya to move along this horizontal plane. And then if ever we exert a force, let's say this is an applied force, then of course, in what direction does this object moves? Siyempre, padung siya sa right, sa right nga kuan, sa right way. And then of course, if we considered here some frictional force, let's say na roughness ang ground, so you also have a force acting to the left, which is our frictional force. Of course, this is the resisting force. Mao ni siya nagpugong sa pag-move sa ato object. Now, since or we assume that the applied force, or we just say APP, let's assume if our applied force is greater than our frictional force. Of course, class, what is your guess? Unsa may indication ani if ever ang pagtuod nato sa object ay mas dako pa sa resist niya, unsay mahitabo sa object? Does it stays on its place or it moves? Unsa man? So mo-move siya tungod kay dako siya. So if ever mo-move nato ang object, therefore we have motion, and since the applied force is related to our acceleration by Newton's law, so therefore we have an acceleration here. But the challenge is the direction of our acceleration. Maybe it will accelerate on this direction, or maybe it will accelerate on this direction. So what do you think, class? Kanang unsa nga direction, what direction does our acceleration point to? Unsa man, ngadto sa right or ngadto sa left? Inyong intuition, asa man kaha? Possibly sa right. How about the others? Unsa man, sa left or sa right? Okay, so actually, so ato sa erase diri. Actually, ang normal nga notion sa tanan jud, or ang notion jud niini is that, of course, since this object moves to the right, of course, nadyo uban normally mo na gyud sila nga ay acceleration is, the direction of the acceleration is, so what is the right? Mathematically you are correct, but by using the Alambert's principle, so man siya nga tawhana, the Alambert's principle, natay gitawag nga reverse effective force. So if you're going to analyze it using vector notation, actually ang direction sa atong acceleration, class, is opposite sa ato resulting force. Kung siya opposite if ever move ang object padung sa kanang sa right, di ba kani? Given this condition, class, na greater than si applied force, so if ever greater than si applied force, ang atong direction of motion is towards the right. So kani di ba? Kani direction of motion is towards the right. So if ever ang atong motion is towards the right, so maya siya nga mo represent siya ani. So this represents our motion. By the Lambert's principle class, since ingon siya nga an object in motion nga subjected to an external force or applied force, natay gitawag class nga reverse effective force. And what is that reverse effective force? It is related with our acceleration. So therefore, ang direction gid ay class by vector notation is towards the left. Okay. So maybe some of you naglibog nga nung acceleration sir kay ngadto man pa left nga nung opposite man siya sa direction sa motion. So again, mo gini yung kitaan class para di mo maglisod pag analyze sa acceleration force. So mara gini nga keynote. If ever ang motion nato is towards a particular direction, let's say towards the left, towards the right man eh. By the Lambert's principle, naatay reverse effective force which is related to our acceleration opposite to our motion. Kay siguro maka-notice mo niini, let's say sakay mo sakyanan ha, kabantay mo if mo accelerate na siya, so what happens sa imong body? Unsa imong ma-felt like banyakan din imong acceleration. Unsa may tabo sa imong lawas? Sige daw kung kung naka-experience mo ni ana. Unsa may tabo sa imong lawas? Malabay ba ka sa atubangan or mura kag malabay sa luyo? Unsa man? Malabay ka sa luyo, mura kag makabilin. So mao na siya effect sa kanang gitawag nga the Lambert's reverse effective force. So therefore kana imong na felt class nga mura kag mahabilin due to the inertia pod class, and then inertia is somewhat related to our acceleration force. So therefore ang kanang mibiran nimo mana siya ang direction sa ato acceleration. But katong storya nga or katong first answer nga ang direction sa acceleration is towards the right, pwede to siya mathematically. Pero in reality class, if we really look at the direction of the actual acceleration gid class on sa based on the class, if magbase ta sa unsay nahitabo sa reality, mao gini siya dapat ang acceleration. Again, how about class? Sige, nag-move ni siya ha. Based on this class principle, how about if mo break na pod ang usa ka object or mohunong siya, what will happen? Our frictional force here is now greater than with our applied force. Kasi diba, break ba ka? So kusog na kay ang mo resist nimo, magay mo stop ang object. So what will happen to the direction of our class, of our motion now? Based on this, frictional force is greater than applied force. Asa naman siya? Towards the right or towards the left? Asa naman? Class, asa naman siya? Towards the right gihapon? Dako naman karon ang ang frictional force. Let's say kani siya nga condition is nag-brake ka. You applied a brake. So asa naman? Since greater than naman ang ato ang frictional force, meaning kani siya nga vector, kani nga force vector, kay padako na. So mas dako ni siya. Mas dako ning frictional force. Dako. So unsay may tabuan ni? Asa man ang atong net force? Okay. So towards the left na ni siya class. Kay dako naman. Diba diri dako si applied force. Ang direction sa atong motion mo follow pod sa dako nga value. Here, since dako naman si frictional force, since nag-apply na tag brake, so let's say nag-move man ni. So kaning first condition, mora mo gini class ato masugatan sa mga sa mga problems nga involve acceleration forces. Object that is moving, object nga kanang kanang subject for braking class. So yung brake siya para mahunong. So here, since dako naman ato frictional force, and then what is the direction of our frictional force? Towards the left. So therefore, ang kanang resulting direction sa atong motion is towards the left na. So in this second condition, may ani na siya class. Our motion here is towards the left. How about our acceleration class based on the Alambert's principle? Asa naman siya? O pa-right na siya. So have you experienced this? Nga if ever mo brake ka, asa ra ka malabay? O patubangan ka malabay. Mo na siya man experience class kanang reverse effective force by the Alambert's principle. So again, if we are going to solve this one, the first and the second condition. So let's say a first condition is kanang nag-move ta. So here, applied force daw. So let's say summation of forces along horizontal must be equal to unsa man, di ba kay di naman zero kay nag-move na siya. So first thing is without using ni siya, ang first nato is without using free body diagram. So summation of forces horizontal is equal to mass, of course kay since we're dealing with force, and then acceleration. So acceleration here A. So this is positive. Why? Nag-move man ta. So if natay motion ngadto ta, so positive atong acceleration if the object moves. Okay ha? Positive atong acceleration. And then i-consider nato nga ang mga forces horizontal, if ever naka point siya towards the right, we take that one as positive. So that's why we have this one. So unsa may mga right nga force nga nag-apply, so we have applied force, then minus, since ang atong frictional force is towards the left na, so therefore kana siya subtraction or minus sign. So we have here frictional force is equal to our mass times acceleration. Again, summation of forces here is dili na zero. Kay ano gali? Tungod kay may accelerate naman siya na may net force. So here, mo na siya ang ato ang equation. By using this, kaning summation of forces. But, if we're going to use free body diagram, libog gini siya kay ngano. Sir, yung ka nga direction sa mass kay nganong positive man ni aring mass time acceleration. Tapos ang acceleration direction sir kay towards the left. Okay. Actually, if we are using this summation of forces, but if we're going to use free body diagram, we can verify nga ang kang the Alambert's nga principle class is correct. Why? In free body diagram, of course, you need to resolve all the forces that are present in our system. So here, of course, natin applied force ari. F applied force towards the right. We also have frictional force towards the left. And what are the other forces class nga nag-act ani? Of course, by the Alambert's principle, natay gitawag nga reverse effective force. Actually, ang free body diagram ani class, ako lang i-consider is the horizontal forces na lang. Actually, you can write all the forces nga nag-interact whether in horizontal and in vertical. Ato like sa free body diagram, ang horizontal lang ang mga forces para ma-relate naton ining first nga method. Okay, so here sa horizontal nga force natay gitawag nga REF. Again, unsa ra to? By the Alambert's, REF stands for the reverse effective force. And this is equal to our mass times our acceleration. So related na siya class. Related na siya sa ato ang acceleration. So these are REF again. Since ang atong direction sa motion class is padungad to, so unsa ra gud to ang REF nato, that is opposite our direction of motion. So mo lang iyahang direction is towards the left. So if we resolve all the forces here, so gamit ang putag summation of forces horizontally, this time since na-resolve na nimo tanan, unlike the first nga wala pa nimo na-resolve, so mag-zero na kanini. Why? Nga mag-zero man ta ni sir, since dili man siya static. Actually, if you considered all the forces gid class interaction, including the acceleration forces, then we can say nga kani siya nga given is kanang we can equate all the forces zero. Since na-consider naman nimo tanan. Unlike here, duha ra mong i-consider sa first nga method ang applied force or frictional. That's why miingon ka nga ang total nila is na siya acceleration. Here, di-consider naman yung acceleration, so we can say that we can equate all the forces to zero. So here, again, take a positive force if it points to the right. So sa may nag-point sa right, applied force. So F applied. Since ang frictional force and the reverse effective force kay pa left siya, so subtraction sila, REF. That is equal to 0. Again, unsa ra REF? From our definition here, is equal to mass times acceleration. So at ibutang, so we have here F applied minus frictional force minus mass times acceleration is equal to 0. Here we can transpose mass times acceleration, so we now have FAP applied force minus the frictional force is equal to mass times acceleration. Now take a look, di ba? Pareho ra sila. So, katong miingon nga ang direction kay towards the direction of the motion, actually correct siya mathematically in this first method. Pero on the second method, since nag-deal naman siya sa exact direction gid sa ato acceleration, now mali siya in a part. But overall class, same raman, maka-arrive ra ka og same nga equation. But take note, nakasinati mo ko ani naka-experience ko nga hinggamit ko ato nga convention nga mao ra gito ang direction sa acceleration kay direct same po sa direction sa motion. Be mindful gyud pag ana nimo, pag summation nimo sa forces, kay ngano masayop ka during the second condition. Ang saragot ng second condition, what if mag-break na ka? So braking, here sa braking, if mo gamit ka sa first method, summation of forces along horizontal gyapon, so nag-break na ta kanina ikaduha, we already applied brake. Since nag-apply na kag-brake class nga, mi consider gyapon ka sa first, meaning ang imong acceleration is negative na, negative mass times acceleration. Kay nag-brake naman ka, so mag-negative na siya, kay pasabot man gud ning kanang negative, opposite na siya sa imuhang kanang gi-assume nga direction sa imuhang motion. So if ever dili nimo siya i-considered class, mo arrive ka sa wrong answer. So mas better if imo i-apply ang gitawag nga D'Alembert's principle, katong reverse effective force. Kay kani siya class, sure good ni nga maka-arrive ka sa exact nga equation. So here, by using D'Alembert's na lang, kay D'Alembert's principle, di ba during braking, ang aton ini, so man siya FBD, kay kang D'Alembert's better niya FBD. So here, again naghihapon tay applied force, so this is F applied, and then of course natay frictional force FF, and then here, since diba nag-brake man ta, so unsa may direction sa atong reverse effective force or REF, asa man, is it towards the left or towards the right? Unsa man class, what do you think? Since naman ta, nag-break naman ta. Nag-apply naman tag break. Ato naman gipa-stop ang ato ang object. So base ra ka diri class. Base ra ka, di ba? Nanatang ingon nga ang motion is padong na sa left kay nag-break naman ta. Then of course, by the Lambert's principle, natay gitawag nga reverse effective force. So pa-opposite siya sa motion. So asa naman ang direction sa ato ang reverse effective force? So pa-right na siya. Since nag-break naman ta, so di ba? I-remember lang nimo nga kung break ka, malabay ka sa atubangan. So therefore, ang atong reverse effective force here is towards the right. So ato yan ay point ngadto. So that is our REF. And then of course, summation of forces na ta. So summation forces horizontal is equal to 0 since naka-FBD naman. Then naka-define na pod area ato ang kanang kuan, ang ato ang forces tanan. Then you can say that it is positive if it points to the right. Okay, so here ang sa mga positive mga forces are, so we have applied force, then plus our reverse effective force minus our frictional force is equal to 0. Here class, as you've noticed, so we have here FAPP, applied force, minus frictional. If we're going to transpose this reverse effective force, di ba negative siya? Kasi since positive naman siya ara. So wait lang, may nag-join. So nag-positive naman siya now. Positive na siya, pag-transpose sa negative siya. And then what is again the reverse effective force? That is equivalent to mass times acceleration. So we have negative mass times acceleration. So here class, ato makit-an class nga nag-negative na siya. That's why sa atong notion ari, di ba? So you can notice negative na siya dari. Okay, di ba? Since pasabot ani class, may decelerate ka. So therefore, sa ato equation ari applied force minus frictional force is equal to negative. So here pod class, if mo follow rata sa katong ato ang summation of forces is equals to the net force, again kung nag-break ka, mag-negative na. Kaya nga naman, ang atong motion there is may decelerate. So we have a negative acceleration kay mihinay man. So here, you can say nga F application or F applied force minus the frictional force is equal to negative of mass times acceleration. So therefore, both methods come up with the same equation. But I suggest class na you will use the second method kanikan di Lambert's kay mas kuan man siya, mas kanang lower ang chances nga maka commit mong errors. Okay, so far na question or wala? Na question class, wala? Wala na. Okay. So, let's have an example sa ato ang acceleration forces. So, this is a kanang popular ni siya nga problem sa acceleration forces. Mara siya gitawag nga atwood machine. So, sa atwood machine, you have two kanang masses suspended by this wire rope niya, attach siya sa pulley. Kani siya, muna siya atong gitawag nga pulley. This is one of the machine elements. And then kani, we have mass 1. Then of course, it accelerates on this direction. So actually, ang gi-point out ni class ha, di ba naing answer ato nga ang direction sa atong acceleration is the same with the direction of our motion. Pero ang unsa may direction sa atong reverse effective force niini? Sige daw. Kung na-remember niyo ang second, di ba unsay direction sa atong reverse effective force niini? Is it upward or downward? Sa main class? Oh, downward ang ato ang reverse effective force niini ha. Kaya ang gipasabotan ning arrow class kani siya. Mo ni jay direction sa atong motion. So para di maglibog, direction of motion. And then by or mathematically mo po na ato ang na kuan na siya naanad na tanga mo na po na siya direction sa ato ang acceleration o direction of motion or direction sa ato ang acceleration. Ay mo kalibog class ingon ka sir ang direction sa acceleration kay the same sa reverse effective force. Kana yun nga reverse effective force magina siya direction sa acceleration nga atong na feel in reality. So para di mo maglibog na lang anyong itawag aning direction sa motion mapud na siya direction sa atong acceleration mathematically. Unya ang opposite niya imo lang to i-denote nga mo na siya nga ato ang reverse effective force or REF para di ka maglibog. Mo siya reverse effective force. Again para makakuan ka di ka malibog sa reverse effective force opposite yan siya sa imuhang motion. Kay di ba imo na siya i-relate sa reality. Mo-move kay ang object or ikaw mo-move ang bus, malabay ka sa likod. Mo na siyang REF. If mo brake po ka, muhunong ang object or mo decelerate ang object by a law of inertia, malabay po ka sa tubangan. Mapod na imo ang reverse effective force. Okay. So continue ta. The problem here or okay, ato na po ni i-continue lang po ang second mass. So if ever na diri imo acceleration, again napud diri ang imong reverse effective force. So kung malabay din ni siya padung ubos, ang reaction sa iya acceleration is pababaw. Okay, again ha, mo na siya atong pag-analyze. So here, the problem states that two objects of mass m1 and m2 wherein m2 here is greater than m1. So igid ni siya specify class nga our second mass is greater than our first mass. Why? Nga naman nga dapat gid greater than si mass 2 kaysa mass 1. What happens then if I will say mass 1 is greater than mass 2? Sa day may tabo class. Class, masaya may tabo. If mudako si mas 1 kaysa ni mas 2. Okay, so mobali pod imong motion. Imbis nga atong motion ni ani is padong ka sa padong ari ha. So kung si mas 2 gay mas dako ni mas 1 ang direction sa motion kay pana. Kay dako man eh, mabugat man eh. Siyempre mahug yun ni padong adto. If ever si mas 1 gay mas dako ni mas 2, of course, mabali na pod atang direction, mara na pod. Padong na pod ato. So that's why gi-indicate ari nga ang mas 2 should be greater than mas 1. Then connected sila by a light and extensible cord and hung over a frictionless kanang pulley. So we neglect na lang sa weight sa rope. In reality, na siya weight diri, di-neglect na lang for the purpose of simplicity. And then as in the figure, so nasa figure, then both cord and pulley have negligible mass. Again, wala sila mass. Find the magnitude of the acceleration of the system and the tension in the cord. Okay, buhato na to na ni class. Again, if we're going to analyze forces of a system, you need to have a free body diagram. So here, kung mag-apply pa kag free body diagram, again, you are going to do it per object or kanang per body ay makitaan sa ato ang system. So, let's do FBD. Again, how many objects class do we have here sa ato ang problem? duha. Okay, duha. So let's start with FBD at mass 1. Okay. Again, mag-FBD ka. It depends upon the number of your kanang body that is or that are present in the system. So since natay duha, mass 1 and mass 2, so we have two FBDs. So first, we have FBD for mass 1. So you just assume nga we have a body here represented by this point, M1. Then what are the forces that interacts M1? So since M1 nagpossess man siya mass, therefore gibira gid siya by the Earth's gravity. So we have here mass 1 times the gravity. What else? Since na may rope naka-attach niya, so again, if na kay rope unsay ro na nga type sa forces if natay rope gibira ka unsay tawag ana? Remember the three forces katong tensile, compressive, and shear. Asa mo ito maklasify na to ang rope? Nagbira man ka. Okay, tensile. So again, unsay direction sa atong tensile? Kung nag-pull ta, is it towards the object or away from the object? Unsa man, nagbira man ta? Is it towards our mass? Paing-ani ba siya? Kung tensile, paing-ani ba? Or pangadto? Unsa man? Kung tensile gani, meaning you pull the object. So what happens? What happens to our direction of our tensile force? Unsa man? Wala. Okay, nadre upward. So since tensile man ta, so again you pull the object. So kung aton gi-pull ang mass 1, so unsay direction? Upward. So we have here an upward direction, and then since it is tensile force, so we label this as capital letter T. So tensile na siya. Mo siya tension sa ato ang rope. And then again, unsa ra gud toy kuan? Since ang atong motion ani class is padung mo siya ngadto, kay di ba? Mo-move man siya pangadto. So this is the direction of our motion. And this is also the direction of our kanang acceleration mathematically. Or ato na ikon nga, mo na siya ato ang theoretical acceleration. Kay lain man tong actual na acceleration. Kaya ang actual nga acceleration nga atong ma-felt kay opposite man siya sa atong motion. So since mo ni direction sa atong motion class, so again by the Lambert's principle, ang direction pod sa ato ang reverse effective force is opposite sa motion. So butang kag dira. This is our REF. Now, after having the FBD, so we are now ready to solve for the forces. So summation of forces along vertical is equal to 0. Since present na ang forces, we are now ready to equate that one to 0. Again, unsa may mga forces nga nag-interact sa vertical? So let's consider muna positive ta if it points upward. Sign convention. So what are the forces that points upward? We only have tensile. And the rest is negative na siya. So we have reverse effective force minus mass 1 G is equal to 0. Again, unsa ra gud siyang reverse effective force class? This is equal to our mass, and then since our mass is m1, so we have here m1 multiplied by the acceleration of the first. So since given mata a1 dire, so a1 la to put ato i-label. Okay. So we have here, kung ato na i-substitute, so we now have t is minus mass 1, acceleration 1, minus mass 1 G is equal to 0. So this would be our first equation. Or you can combine, since mass 1 is common to the second and last term, so we have T minus mass 1, then acceleration 1 plus the gravity is equal to 0. So you can rewrite this. And since we're already through with the first object, So let's jump with the second object. So FBD at the second object, mass 2. Okay, so draw a point that will represent your second object, mass 2. And then, again, unahon nimo, since naman siya gravitational force, so we have here a downward gravitational force. We have mass 2 times gravity. And then class, here, what is the direction of our motion, class, for the second object, mass 2? Downward. So importante gyud nga i-write nimo ang direction sa motion. So this is the direction of our motion, paubos. And kung nagpaubos siya, unsay interaction sa atong rope. Kung nagpaubos siya, mubira po na atong rope. So ang atong rope, mubira ni siya pababaw. So therefore, we still have tensile. And this is upward. So again, kung rope gali, class, wala na siya kuan, ha? Wala na siya possibility, wala na siya chance nga mutuod na siya. Unlike kung naka-spring, rope man na siya, so more or less tension gina siya i-exert. Mabira na siya. And then since, class, ha, kung nag-wonder mo why ang tension nato sa ato ang mass 1, sir, kay equivalent ra gihapon siya sa tension sa mass 2. Since they are connected, class, so nga siya, class, ha, ang tension nato, class, tension nato sa rope, since kani siya nga rope, class, kay uniform na siya, walay elasticity, and then uniform na siya, then since connected man sila, class, kung unsay tension diri sa mass 1, class, mao na tension sa mass 2. Yes, we can verify that one later on siguro if we're going to derive frictional force for a belt and a pulley. Since walay friction diri sa ato ang a pulley, class, and actually din siya belt, this is a rope. So since walay friction nga nag-interact sa rope o sa pulley, meaning walay nagpugong ari. So therefore, kung unsay bira diri sa rope sa mass 1, mao po'y bira diri sa rope sa mass 2. So that's why I have here the same representation, T. Okay, what else, class? So since nag-accelerate man ta, again natay gitawag nga reverse effective force. So unsa man ka ang direction sa atong reverse effective force, class? So ako na ginang gi-drawing ara sa figure. Syaro, unsa man? Sa may direction. Okay, upward. So, butang ka upward. So, this is your reverse effective force for the mass 2. Then, summation forces along the vertical is equal to 0. Then, let's take the positive force if it points upward. Okay. So, since duha man na to ang mga vertical forces, so we have tension plus the reverse effective force minus the weight, mass 2g, is equal to 0. And again, unsa ragod atong reverse effective force, that is equal to our mass 2, the mass, and the acceleration of our mass 2. So A2 minus mass 2g is equal to 0. So this would be our equation 2. Since we are going to find the magnitude of the acceleration of the system, so unsa man ang acceleration 1 o ang acceleration 2. Okay. So combine that one, so we have t plus m2, then we have a2 minus g, diba, is equal to 0. So ako nag-factor at ang m2. And then we can also since we're just aftering with acceleration, class, so I can derive this by using the tension T. So I can say from equation 1, so we have T is equal to mass 1 times acceleration 1 plus G. Diba, class? Ako na siya gitranspose nga to para makakuha tag equation sa tension. And then I can substitute this value to the second equation, diba? So in second equation, or in equation 2, so after substituting, so we now have mass 1 times acceleration 1 plus g, plus mass 2 acceleration 2 minus g is equal to 0. Actually, class, if you only have kanang, if the two objects class are connected to each other, ha, yan ni siya class ang kanani. If the two objects are connected to each other, they accelerate at a constant rate. So both of them has the same value of their acceleration. Kaya nga naman, konektado man siya, meaning, mabira kayong usa, mabira po ang usa. Mo-accelerate po ang usa, mo-accelerate po ang usa. Actually, ila lang ni label as acceleration 1 and acceleration 2. Why? Because they consider it as a vector. Of course, vector man acceleration. Kay, here, we can say that the acceleration 1 is just equal to the negative of the acceleration 2. Kasi acceleration 1, pa-point man upward. Si acceleration 2, pa-point downward. More na nilang sign convention. But actually, acceleration 1 is just equal to acceleration 2, or we can just denote this as acceleration A. Kaya nga no, again, ay magkalibog. If connected gali ang duha ka objects or tulo, bisag kaning tulo kani. We have usa ka object, kaduha, katulo, mudagan na sila padung to, same ra gyapon sa acceleration. If walay considered nga kani siya kay na ay friction are, kani siya kay na ay friction are, kani pong sa na friction. So wala gay na pareho sila treatment class, bahalag bugat ning usa, kani usa gaan, kani usa kay medyo bugat. Pareho gyapon sila kay nagkuyo gud sila. Basta kay dili lang ni mo change ang kuan basig rubber band ni mo elastic, so therefore naa di difference. Since ingon man diri nga inextensible ang rope, so meaning dili ma stretch, dili mana, so therefore we can assume nga pareho ra gyud ang acceleration basta kay konektado lang ang mga masses or objects. So here we can say in our equation that this is mass 1, then I can just say this is acceleration, then plus g, and then plus mass 2, then this is now acceleration minus g is equal to 0. So ato i-distribute para ma-separate na to ang acceleration. So we now have mass 1 a plus mass 1 g plus mass 2 a minus mass 2 g is equal to 0. So we can group the acceleration. So a is mass 1 plus mass 2. Then I can also group g. Then I have here mass 1 minus mass 2 is equal to 0. So I can transpose this on the other side. So I now have a is multiplied by mass 1 and mass 2. That is equal to the negative g. Then mass 1 minus mass 2. Actually, I can distribute negative to the terms inside the parentheses. And then I'm going to divide both sides. So I'm going to divide both sides by mass 1 and mass 2. So we now have acceleration equivalent to g. Then this is mass 2 minus mass 1 all over mass 1 plus mass 2. Actually, class, by just looking at the formula, since dako man ni si mass 2 kaysa ni mass 1, the answer here is a positive number. That's why we have a positive acceleration. If ever ang atong mass 1 is dako na ni mass 2, therefore we have negative acceleration. So again, what do you mean by negative acceleration? That is opposite to our motion. So mo nang ingon ko nga kung dako na gani si mass 1, mo baliktad na ang paghug sa ato ang objects. Padung na ato. So therefore, sakto ni ang ato ang convention nga mo gini ang motion niya. Padung adto. Kay makaingon man tani nga formula nga dako si mass 2 kaysa ni mass 1. So we can arrive a positive answer. So, na may question so far? Question. Question, class. Na question? Okay, wala. So, again, naapay usa day ka requirements ang tension na sa cord. Actually, kamo na lang niini since we already now have a value of our acceleration, and then since naaman tay equations sa tension, you can use equation 1 kay naman yung tension, and also you can use equation 2. You just plug in the value of acceleration here. Kay di ba ingin man ta nga ang acceleration 2 and acceleration 1 both are the same, which is equal to the acceleration that we already solved kaning A. So i-plug in na nimo makuha na ka sa tension sa ato ang cord or sa ato ang rope. So let's proceed. The second one is a block with mass 1 equals 4 kilograms and a ball with mass 2 7 kilogram are connected by a light string that passes over a massless frictionless pulley. So again, gi-indicate gina siya class, mao ni ang pulley. Gi-indicate gina nga massless o frictionless kay para di magsangit-sangit, para constant ra nga atong acceleration, and then constant pod ang ato ang kuan, ang tension pod dili mag-vary. And then here it state that the coefficient of kinetic friction between the block and the surface is 0.3. So therefore here class, ang mass 1 it already encounters a frictional force. And then what type of friction? This is kinetic friction. So kinetic na. Therefore na may pugong niya. So na may pugong, medyo di na kay siya ka-move kaayo, pero maka-move gid hapon, hinahinay lang. So the last one is find the acceleration of the two objects and the tension in the string. So I think this is an Atwood machine. The same side ato ang first. This is the application of the Atwood machine. So here na ako'y pangutanan ninyo. Since our mass 1 is 4 kg, the mass 2 is 7 kg. Unsa kay direction sa ato ang motion class? Do you think mabira ni mass 1 si mass 2, or mabira hinuon si mass 1 ni mass 2? Unsa man? Okay, so therefore ang direction sa ato ang motion class is pang-ana. Kay since bugat man is mass 2, mahatak gid siya. So we need to write first the requirements, so standard sa itong solution. So we're going to find the tension of the string and also the acceleration A. So again, take note class, ang gibutan ako sa acceleration here is just A, because since both mass 1 and mass 2 are connected to each other, therefore both of them accelerates at the same amount or the same value. So here, always good class, to analyze acceleration forces or even static forces, use FBD. And since duha ra man nato ang object array, and si pulley di po nato ma-consider nga object kay massless man siya, and then si table here wala siya appeal sa analysis, gibutang ra siya kay kana siya, this will serve as the constraint lang. So wala po tay FBD niya. Si kuan pod, si sanay kani si rope, since light man siya, walay mass, so wala po tay FBD niya. So we only have FBD of mass 1 and mass 2. So let's start with FBD at mass 1. Okay, here you need to consider all the forces, whether vertical, horizontal, or etc. unsa pa na siya mga axis. So here for mass 1, since naman siya weight, gibira gid siya ni weight. So we have here mass 1 times the gravity. And since naman kay frictional force, again, ang direction sa atong motion kay padungad to. So this is the direction of our motion, kaya ihatak man siya. If that is the direction of our motion, unsa bi direction sa atong frictional force? That is always opposite sa atong motion. So it will be on the left side. So this would be our frictional force FF. And what else, class? What else? Unsa pa man jud may act sa ato ang kuan, sa ato ang system? Tension. So since na mibira, since na may string, so this would be the direction of our tension. Gibira niya si mas 1. What else, class? Naa pa jud. REF. Okay, so what is the direction of our REF? That is opposite to our motion. So, nana siya diri. This is our, okay, sorry. Sulat siya. So, na diri ang ato ang REF. What else? Napa jud siya, class? What are kanang other forces nga present for mass 1? Kita ang gini mo siya, class. Unsay nahimutangan ni mass 1? Okay, normal force, correct. Since naka-rest man siya sa table, of course, si table mo exert pud siya ni mass 1. Kay kung why exert si force sa table, matagak man si mass 1. So therefore, we have a normal force there. So we have here the normal force N. Okay, more na tanang forces nga present ni mass 1. So we can now apply summation of forces. So summation of forces, let's say mag-una na lang ta sa vertical is equal to 0. So 0 naman. So here we take positive if it points upward. Okay, masay nag-point sa upward, normal force. Normal force minus unsa pay lain? M1G na lang. Minus sign ni siya kay padung man siya downward. That is equal to 0. Then we can transpose that one. So we now have normal force is just equal to the weight. Okay. So humana ta sa vertical force. So horizontal po ta. So summation of forces along horizontal, that is equal to 0. So we take positive if it points to the right. So what are the forces that points the right? So we have tension, positive na siya, minus ni pugong si frictional force, minus pa gyud ni REF nga opposite sa ato ang motion, that is equal to 0. So wa man tay tension, so T na lang na. Class, do you have any idea what is the formula for the frictional force? So FF equals, unsa ka to? Kung napay naka-remember sa inyo ha, last time nag-discuss ko frictional force. Unsa gyud formula niya? Okay, that is coefficient of friction. So unsa man nga type sa coefficient of friction itong gamiton ni ani? What type of coefficient of friction are we going to use? Unsa man, class? Is it static friction or kinetic friction? Okay, kinetic. So why kinetic? Because it moves and it is also written in the problem or stated kinetic friction. So therefore we use here mu k, then the normal force. Again, don't forget the formula for frictional force. That is just the coefficient of friction times the normal force. So we put here mu k, then n, minus again ay pagkalimti si reverse effective force, which is equal to mass 1 multiplied by gravity. No, that's not gravity, that is the acceleration. So mass 1 multiplied by acceleration, that is equal to 0. Since we already know the normal force, which is equal to mass 1 times gravity, so I can just say that is T minus mu k, then that is mass 1 times g minus mass 1 times a is equals to 0. So this would be our equation 1. Okay, now the equation 1. So let's jump in. Punta na punta sa FBD at mass 2. Okay, for FBD at mass 2, again, just write a point that will represent our mass 2. And then next, sa may mga forces ni ini. Okay, natay gravitational force ni mass 2. So that is mass 2 times G. What else? Since naman naka-attach man siya sa rope, so we have tension towards or upward na siya. So that is T. Again, class, ang sa direction sa atong motion, so pa-downward, kay gihatak man siya paubos. So this would be our motion. So, unsa may direction sa atong reverse effective force? Unsa man? Upward. So, since opposite man si reverse effective force of motion, so that would be pointing upward. So, R, E, F. Class, kung wala ni nag-accelerate class ha, di ka pwede magbutag REF ha. So, for static analysis, walay REF nga naka-present. Kaya nga naman, walay motion nga nahitabo. So, para lang ni sa motion ha, para lang gini sa objects nga naglihok. Okay. So, summation of forces na ta along a vertical is equal to 0. So, nag-vertical na lang ko kay wala may forces sa horizontal. So, we have here positive if it points upward. So, here, unsa may forces nga nag-point upward. So, we have tension plus the reverse effective force minus M2G, negative M2G, kay downward mo siya, is equal to 0. So here, again, our reverse effective force is just the mass of the object. So atong object diri kay mass 2 man, multiplied by the acceleration, minus M2G is equal to 0. So this would be our equation 2. Actually, we can relate the tension for both equations. So we can say that from equation 1, so ato na ni ikan klasa, transpose na natong mga masses are with the respective coefficients. Para from equation 1, we now have T is equal to, actually I can factor out mass 1, or ato na lang isuwat na lang para dili na ta malangay o combine sa acceleration. So if I transpose both these terms on the right side, so I now have positive mu k mass 1 times G plus na pod plus mass 1 times acceleration. So I can use this T value and then I can substitute this to the T on the equation 2. So I can say in equation 2, so T now would be mu k mass 1 G plus mass 1 A, then plus mass 2A. So that is plus mass 2A. So I hope nakasunod mo, ako lang siyang gisubstitutan. Then minus mass 2G is equal to 0. Since we are aftering with acceleration, so ato na ibilin, ato na i-transpose ning duha kana. So we now have A multiplied by mass 1 plus mass 2 is equal to, kani mapositive na siya, so that is mass 2G, kani siya ma-negative, that is minus mu k m1G. Then divide both sides by mass 1 and mass 2. So we have here mass 1 plus mass 2. So we now have acceleration equivalent to mass 2G minus mu k m1G all over mass 1 plus mass 2. Actually, we can factor out the G here para medyo dili siya katagtanawan. So G times mass 2 minus mu k mass 1. Okay, our G is 9.81. Our mass 2 is 7 kilograms. So wala tay problema class sa pag-convert sa mga units kay consistent sila tanan, naka-metric. So we have minus 7 times 0.3 for the kinetic friction. Then mass 1 is 4 cm. So I mean 4 kilogram there, sorry. So 4 kilogram divided by mass 1 is 4 kilogram plus mass 2 is 7 kilogram. So in order to make things clear, so unit analysis, we have for gravity is meter per second square multiplied by this ang 7 in kilogram, so this is kilogram, and then divided by the kilogram. So here kilogram cancel, the resulting unit is meter per second square, which is acceleration. Okay, ato i-erase. So if ever na may calculator, so we try to solve this or try to simplify this. Okay, ato i-simplify. So we have 9.81 multiplied by 7 minus 0.3 times 4 divided by 4 plus 7. The resulting acceleration is approximately 5.17. So this is approximately 5.17 meter per second squared. So this would be our first answer for our acceleration. How about our tension class? So you can use either equation 1 or equation 2. But for me, equation 2 medyo di ka siya libog, so I can use equation 2. Equation 2, I have T is equal to, ako lang na i-transpose daan class sa right side. So I have now mass to G, mapositive ni siya, then also negative minus mass to A. So I can just say mass 2 equals G minus A. So here, mass 2 is 7 kilogram multiplied by G is 9.81 minus the value of our acceleration equivalent to 5.17, an approximate value. So our tension is approximately equal to 7 multiplied by 9.81 minus 5.17. The answer is approximately 32. So this is 32.48 newtons. So this would be our answer. This is 32. Okay, class. Now question. Class, na question? Na question, wala. Okay ra ba ang kuan? Wala ba siya nagkarat? Okay ra ang audio? Okay ra, class? Okay ra? Okay, so wala na may question? Wala na? So let's proceed to the next. So our next topic is, okay, nalta sa torque since we already do with acceleration forces. So proceed na ta sa torque or moment. So for a torque class, this is associated with kanang turning or rotating an object. So if tuyo ko nimo, let's say na akay, say if you're going to open the cup of a Coke or Pepsi, diba kana iyahang cup, so imo na i-open, so you exert a certain force over a certain moment arm or torque arm. So kana siya, kana imo na generate mo na siya gitawag nga torque or moment. So kaning duha if kalibog, torque and moment, the same na sila. So ang ilang kuan is force times distance. And here for torque and moment class, it causes angular acceleration. So okay, since nagtuyok man ka, nag-turn ka sa kabody or nag-rotate, therefore napo kay angular displacement, napo kay angular velocity. And if ever ang imong pagtuyok or pag-open sa kuan, let's say mag-open ka og takob sa Pepsi or sa Coke, so kuan na may uban nga dili magika maka-achieve nga constant imong pag-open, so therefore naa kay acceleration pud niya na ang tawag ana angular acceleration. Then this is also the product of the applied force times the moment arm. So when we say moment arm, this is measured in length. So if we're going to express this one mathematically, so our torque, others denoted this as nga T, then equal to the force man. So this is force times the moment arm, others represent that as R, or ang aban kay force times the distance. Okay. So ang unit niini, since unit analysis, force is in newtons, distance is in meters, so ang standard newton meter. Actually, kung maabot mo sa energy class, ayaw pag-confuse. Kay ang energy pod is newton meter, which is equal to joules. Kani, ayaw ni i-convert ang atong torque into joules. Kay dili man siya energy. This is just the applied force over a certain arm. Then, in order to analyze the torque class, the force should be perpendicular to the moment arm. So, on summary na to, let's say for figure A, so we have here an object. Sa may object nga itong gituyok, kanin siyang nasa center, mo siya gitawag nga nut. Ang nut naka-attach sa bolt. Of course, bolt always comes with a nut. Ang nut, you are going to turn this. So, ang ata diri ang force, dira ka naggunita. Let's say this is your hand. Then dira ka nagkupot. So, exert ka dira og torque ana. So, therefore, imong force nga na-apply kay paingani in this direction. So, therefore, by the definition of our torque, since I told you that your force should be perpendicular to your moment arm. So, this force here is perpendicular to this moment arm. Kani siya mo na gitawag nato nga moment arm. So, perpendicular man siya. That is okay. That is good. Here, on the second figure, your force here is again perpendicular. Okay gid siya. Torque na gina nimo. So, let's say, naggunit po ka diri. So, gunit ka, imo ni siyang gipatuyok. So, padong ang tuyok ani. Kaya paano makapatod mo kang so, padong ang tuyok. The same thing with this, padong ang tuyok. And then, by the last figure, so here, this is also good. Kaya perpendicular man siya sa moment arm. So, diri po ka nagkupot, ana. Imo po ning gituulyok o giliso ang ato ang bolt. Okay. So, if ever gali, na sir, what if dili siya perpendicular? Let's say, my force here is pangadto. In the second figure, my force is pangadto. So, since dili ni siya, ang force ni kay it is not already perpendicular to our moment arm. Kaya mawala itong moment arm kaning y-axis. Kaya hindi na siya perpendicular, you need to resolve. So, again, you need to resolve this force para imurang kwaon ang force nga naka-perpendicular sa atong y-axis. So, if we are going to resolve this, so this would be the resultant. So, this is your f. Let's say this is your fx, and then of course, napugadari fy. So, therefore, ang torque ra nga ma-generate sa imong force is just the component along the x. So, kani nga naman, kanira may perpendicular sa imong y-axis. Kaning y, dili na siya mag-cause og torque. Kay, di man siya perpendicular. So, for a force that is not perpendicular to your moment arm, you need to resolve. Ngayon mo kay kanira may torque, effective torque nga mo cause og rotation sa imong system. So always perpendicular gina. Again, if naka-angle na siya, you need to resolve pa. Yun pa na siya i-resolve. And then another question. So based on our figure, this three figures here that I presented to you, by using the formula, okay, so by using the formula, ako gani padako, T is equals to force times the moment arm, or just say R. Okay, based on the formula, torque equals force times the distance. What do you think, class, among these three figures, asa man nila ang nag-exert of dako nga torque? Is it the first figure, second, third. So medyo sa ang nagkalahi lang sa figure is just the first figure dool ka nag-apply, sa ikaduha nga figure layo-layo na ka, sa ikatulo nga figure layo na jud ka. And then given that the same ra gyapon ang force nga mong gi-apply diri class sa A, B ug C, same ra. So what do you think class? Asa man ang pinakadako nga torque nga na-generate? C? Sige daw, nganong C man? Class, nganong letter C man? Okay, since in our formula, so force times radius, since constant man ang force, okay ra ni. And since for letter C, dako naman yung moment arm, so yung taas naman ka, yung layo naman ka. So if ever this R increases, and since the relationship of our moment arm and the torque is directly proportional, so kung mudako si R, mudakot po ni si torque. So mao na siya mao na siya advantage sa atong mga machines karon. Let's say if you have a lever, so due to torque class, let's say na diri na kay fulcrum or pivot. Now pwede ka ka-lift og object na heavier object, let's say mo na yung object, then nakalagi butang, so mo na siya something kwan. So if ever taas ka ni siya class, then ikaw ni siya, so pwede na nimo ma-lift kaning bisag massive kani nga object M tungod kay dako naman imong force nga ma-generate. Again, makatuyo ka or diri kani nga sense kay maka-lift ka. So imo ning maana, mo man ang rotation, maka-lift ka. Kung diri ka mag positions dool class, diri ka sa dool kana gyud ba bug-ata jud ana tungod kay gamay ang imuhang R. Sir, uban jud, uban nga mo debate jud. Sir, maka-lift ka sir kaya naman maka-modify maka sa imuhang formula sir nga torque kay pwede maka exert og so much force. Of course, kung tao ra ka, limited ra imong force nga ma-exert. Siguro kung na machine, pwede gud ma-lift niya. But in our example lang, tao man ka naka-limitations, so therefore limited ra imong force nga ma-exert. So mas better if magpalayo ka sa kaning ato ang fulcrum or pivot point. Palayo ka para modako ang imuhang R o niya gamay ra imong force nga needed para maalsa nimo ang kaning bugat nga object that has a mass of M. Okay. Nasabtan ra. Okay, sabtan ra. Mo na siya basic principle sa atong torque or moment. So, let's try to solve mga torque problems. Okay, mag-solve ta og kanang mga torque problems. So again, mo na siya ang kanang kuan. Mo siya tong figure. Say this is our figure A, and then let's try to solve this. Let's say if you want to lose, okay, you want to lose this nut. Imo siya i-lose ang nut. So therefore, imo na siya i-turn counterclockwise. So kung counterclockwise kay right-handed man siya nga thread. Right-handed thread, so counterclockwise maabli siya. Ma-lose. Let's say I have here a force. So nasa force array. And then this force is equal to 100 newtons. Angled 30 degrees. Okay. So what would be the resulting torque of this? In sa man class, solution. So kanang gusto ko nga kanang kamoy mo dikta na sa pag-solve niini para pod makakaton mo. So unsa may atong unang buhaton? Is it correct to say that torque is equal to the force multiplied? Let's say I have here a radius of 15 cm. Okay. Is it correct nga mo na dita force times radius? Okay, so unsa may atong unang buhaton niini? Okay, we are going to resolve the force. Since, mas ito ang gingon, torque is always perpendicular to our moment arm. mao man niya itong moment arm class. This is our moment arm. So since si force kay dili pa perpendicular, so ato ni i-resolve. So naa na siya component ari. So in resolving, follow ka sa right triangle. So kani siya na right triangle na ta. So this is component along y and this is component along x. Since si x is opposite sa angle nga 30 degrees, so I can fx is equal to the f sine of 30 degrees. So that is just 100 sine of 30 degrees. Okay, so therefore pala, ang torque natin dire is equal to fx r. So di din ni mao. And then for fx r, that is equivalent to 100 newtons sine of 30 degrees and then multiplied by our radius. Ang sama itong radius class? Let's say I want to have a torque in Newton meter. Ang sa ibahatan natin sa itong radius. Okay, convert. So since we have a moment arm of 15 meters, so that is 15 all over 100. Kaya ang 100 centimeter is equivalent to 1 meter. So if you have calculator, you have 100 sine 30, then multiplied by 15. So that is 15 over 100. Then the answer is 7.5. So this is 7.5 exactly. 7.5 Newton meter. Okay. Sabtan ra? Sabtan na class? Okay, mo siya is simple way to solve for torque and moment. But how about if naanatay mga two or more forces nga nag-interact sa atong system, since this is just a simple kanang analysis sa torque. But if ever na ay mga tanan ninyo na ay nag-wonder, sir, unsa dining ito na erase, sir, unsa din gi-represent aning yellow, kaning yellow nga arrow, nganong nag-point na siya upward, sir? Remember sa atong vector nga discussion, di ba? Kani siyang pag-solve og torque and moment gamit ta og cross product. Again, itong cross product, if you have a certain entity or a certain vector A and certain vector B, let's say if A cross B, so always perpendicular na sa A, di ba? Ma-relate nato sa ato ang torque here kay di ba ingon ta nga ang vector force should be always perpendicular to our vector nga moment arm. So mura pa na siya A cross B. And then ang resulting vector ani kung mag cross product ka is away from the plane of AB or towards the plane AB. So mao gina resulting vector sa atong cross product. Mao ni gi-represent sa ato ang yellow nga arrow diri kung nakabantay mo. So ang pasabot pud aning direction sa yellow arrow class sa atong torque na nag-abli man ta ani no. Pasabot ana na loose siya mo nang hingpoint siya upward, meaning na loose ang ato ang nut. Now kung pabalik ko ako ni siya ang force nako kay pa clockwise na. So kung diri akong force, ang direction sa imong rotation kay pangadto pod. Ngadto man yung gitod. So therefore clockwise na ka. Ana. So therefore kaning arrow ni mga yellow mabalin na pod ni. Mangadto na pod ni sa ubos. Diri na pod ni. Meaning unsa man ka? Nagpa-tighten ka sa imong nut. So imo nang gitight ang imong nut sa imong bolt. Mao na siya gi-represent sa yellow nga arrow dira class. Okay. How about if you are given a lot of kanang vector forces? So sa system daghan na kaayo. So what will you do class? Let's say for static analysis, class kaning static analysis di lang ni siya it is not only kanang limited to forces. Actually ma-applied po ni sa atong moment. So in what way, sir? In what way? Let's say I have here a pivot point or a fulcrum, then nakay kuan diri stick. Naka-stick. And then, actually, basic ni siya sa principles sa torque and moment arm. Let's say, ang kanin siya, ha? Or, para makanin nyo, let's say, seesaw lang na siya. Sige, seesaw, para ma-imagine din ninyo. Unya, nagbutang ko dig weight. This is mass 1. Then, napag-weight ari nga, mass 2. Of course, kani silang duha ka mass na, gani sila ay radius. This is radius 2. Or na sila yung mga distance from the axis. So, kaning moment arm class, ang definition sa moment arm is the distance from the applied force or the distance of the applied force from the axis of rotation. So, kani siya, mo man itong axis of rotation. This is a letter ing figure. Axis of rotation. So, for our analysis, diri, mo pa itong axis of rotation. So, man siya axis of rotation. And then here, na napawig suspend diri nga mass 3. And then sa last, napagta diri mass 4. Sa mass 3, we have R3. So, manay moment arm. Then sa mass 4, we have R4. Okay. Class, if ever wala ni rotation, so let's say, assuming class nga wala ni naglihok, sa ibuhatan nato niini, you can do summation of forces, but at the very best nga pag-solve ani is summation of moment. But class, again, ma-apply gyapon na yung summation of forces. Sige daw kung naapay nakahinumdom sa atong static analysis for the force. So, forces. Summation forces along vertical is equal to 0. Kaya inyo man ta, wala ni siya nag-move, kay static man ta. So, class, unsa may mga forces nga hing-act on the vertical direction? Let's say, positive forces upward. Sige daw kung nakainamdom. Based ani nga figure, unsa may mga forces nga ni-act along the vertical direction? Okay, gravity by each. Okay, gravity by each mass, di ba? Each masses, di ba? Okay, so weight nila tagsa. So we have here since downward man sila, so negative. So that is negative mass 1g minus mass 2g minus mass 3g minus mass 4g. Class, tanan na itong mga forces diri class kay padong downward nya. Napabatay lain nga force nga nang-interact sa system. Kay kung iani atong system class, mahug din ni paubos. Kung sa pamay laing force daw nga may interact na ani, sige daw kung naabadyo na pan niyo. Kung sa pailaing forces nga ni-interact sa atong system, normal force, actually normal force dili siya fit kay wala man, let's say wala man ni nag-rest sa surface ning kaning mga masses nato, since naamon siya nagbitay ra man ni sa aning string. Yes, for the tension, but since ang tension kay connected na pod sa ani kani, kung mag FV dito tagsa pwede na inyong assumption nga tension ta diri, but I consider the entire system. So unsa man, if mubira ni silang tanan, of course unsa may nagpugong ra para di na sila mahatak pa ng ubos based sa system. Yes, na uban tension, but kanang try to consider the bigger picture, the entire system. Actually, this is the sa fulcrum. Kani di ba ang fulcrum may nagkupot sa tanan, so natay force dira. So this is force reaction, di ba? Ni-act ni ang tanang forces paubos nagkay reaction. So unsa may reaction naa sa imong support man ning fulcrum class kani, support man ni take note, support. Okay, good to inyo ang pag-ingon nga tension class kay gi-suspend the string, but that is only for FBD. Kung imo siya i-analyze every mass. Pero akong ikuan diri kay the entire system man, the whole system. So here, natay gitawag nga resultant force. Kay mo ni siya mo counteract sa ato ang weight. So that is plus Fr equals to 0. So mo na siya ato ang static analysis using the force. Kaya di ta pwede wala tay resultant, reaction force ha. Again, for static analysis, for every action, there is equal and opposite reaction. This is the reaction force and this is the applied force. Kanitanan, applied force ni sila. So, kanina sila, equivalent na siya sa Fr. Okay, nasabtan na? Nasabtan na? Okay. So, the second analysis for static is the moment or the torque. Okay. The moment pod class or torque, natay gitawag nga summation pod. So, ang pag-denote ana is summation moment. Let's say, ang moment class, di na siya ingon nga along vertical, along horizontal. Di ba kay ang torque og moment kay with respect to an axis of rotation? So, here, ang sa may tendency ani nga mga masses nga magtuyok sila. Di ba along this fulcrum? Di ba kani? Mura ba ni siso? So, matuyok na siya dira. So, mura na imo i-consider. So, summation forces along the axis, let's say, that is axis O. So, axis of rotation is O na lang ato pag-represent. So, for static analysis class, wa man naglihok. Meaning, unsa may resulting moment ani kung dili ta maglihok. That is equal to 0. So, okay, so 0. So, summation of forces for static analysis is equal to 0. So here, ato i-take class, same ra gyapon ni siya class sa pag-analyze of forces. Let's take a positive torque or moment. If it rotates, ikaw bahala. Pwede ka mag-positive sa counterclockwise, pwede ka mag-positive sa clockwise. So I'll just assume nga positive siya if it rotates clockwise. Okay. Basig napa sa inyo wala kay ba ang sa rotation clockwise gali kanang hinsunod gali sa pagtuyok sa orasan mo si clockwise. Wala gay misunod sa tuyok sa orasan, counterclockwise na siya. Okay. Unsa may atong una nga force nini? You can select but ato i-consider ang mga forces nga maka-cause siya rotation sa atong system clockwise. So ang clockwise rotation kay paana. So diri si mass kay padung manig ubos, so meaning sila ang clockwise, si mass 3 ug si mass 2. Kaning mass 1 ug mass 2 class, padung man siya ani, meaning patuyok sila ngadto. Class, do you get the point? Nasunod ra? Kana okay. Oh, magtuyok man siya. Kaning si mass 3 si mass 4, birahon man padung clockwise. So I can just write here the force of mass 3, so that is mass 3 G. Onya ingon man nga ang moment or torque is multiplied by distance, so that is m3gr3 and then plus duha man sila nga clockwise, so plus m4gr4 minus na ang sunod kay ang kaning m1 ug m2 kay counter clockwise naman ni sila, so subtraction na sila, so minus m1 gr1 then minus m2 gr2 is equal to 0, or you can factor out G. So you have G, then M3R3 plus M4R4 minus G, then that is M1R1 plus M2R2 is equal to 0. Actually, you can multiply both sides by 1 over G para mawala ang G. So that is M3R3 plus M4R4 minus M1R1, then pwede put minus M2R2 is equal to 0. Okay, this is now the resulting formula for your summation of moments. Kana siya. Nakoy question. Sir, di ba sir na-apply laing force? Di ba na-apply resultant force or reaction force? Sir, nga nang wala nimo siya gi-include pag summation of moment na. So, ang saman class, why? Nga nang wala na ako gi-include ang reaction force sa fulcrum kaning FR. Kay di ba dapat kung mag summation moment ka, consider tanang forces. Nganong wala na ako gi-appeal ni akong gi-circulan karon. Kani nganong wala man na ako gi-appeal. Ha? Unsay again? Mutuyok. Kuan, any other kanang pwede, pero napigid siya exact nga reason why we not consider FR. What else? Based sa formula gid class, formula gid ta. If magbase ka sa formula sa torque F times R, ang sa may makuha nato, again R is the distance from the axis. Again, okay, so 0 man. Kanang mo-agree ba mo? Mo-agree ang tanan? Na 0 daw ang radius. Mo-agree? So, since ang atong reaction force is acting along the axis of rotation, di ba? Along gini siya. So therefore, our R here is 0. So di ba? Tanang galay mga forces class nga may act along the axis of rotation. Therefore, wala na sila na-generate nga torque. Bisag ikaw sige dabi, itod ni nimo class. Do you think makarotate ka ani? Do you think makarotate ka og not kung imo ning itod ning kaning wrench? Itod-tod ra nimo padong axis, di ba wa? Tungod kay imong moment arm kay 0. Okay, nasabtan ra? Sabtan ra. Okay, I hope nakasunod ang uban kay wala mo mga pangutana. So here, I think I already discussed the equilibrium condition. So kadto na lang, summation of forces and summation of moments. Actually, ato na sila usahon ng duha. Di man na pwede magbuwag ng forces and torques and moments. So kato rin na, summation of forces vertical and horizontal, summation of moments at the axis point or the axis of rotation must be 0 for static. So let's jump with sample problems. So problem number 1. So we have here a figure and data. So natay diri drawing, this is a rod. So here the requirement or the statement of the problem is that we are going to calculate the net torque, magnitude and direction on the beam in figure 8.5. So can you see this is from the book. Then about A, an axis through O perpendicular to the page. So can you see there about an axis, and then B, an axis through C perpendicular to the page. Okay, mao man ang page ana. So therefore atong first axis is asa good class. So let's say axis O. So therefore, since giingon diri sa problem nga axis O ang una nga requirement, perpendicular to the page. Okay, so asa ang axis O? Kani siya. Class, asa man ang ato ang second axis? Di ba naman tayo letter B nga question or requirement? Asa man siya malocate? Sa letter? Asa man? Sa letter? Letter C. Okay, sakto. Letter C. So, start na ta sa letter A. So, again, sa tayo bahaton, summation of moment na lang ta. Kay, pwede good mo mag-summation of forces but wala mo gamit class kung mag summation of forces ta. Why? Because ang gipangutana so conjugate mas better kung una gini mo suwaton ang requirement. So ang required man kay net torque. So meaning that is summation of the torque or moment. Okay. Here solution. So unang gihingan ninyo. Analyze gid sa ninyo ang problem kay basi mo na nga maana ninyo sa summation moment equals 0. Again, so take ani, this is only for static analysis. So meaning wala nag-move ang system. Since ang gipangutana kay summation of moment or torque, di ta mo gamit anang 0, 0. Meaning, wa pa ta kay ba, may gipangita. So therefore, I can say summation of moment along O ta ha, so butang ni mo nindot nga pag annotate og moment, imo butang kung asang axis, imo isub. Summation of moment sub O is equal to we don't know kay mamay gipangita. Then we just take positive if it rotates clockwise. Or kana siya mo na gitawag nga net torque. So kung unsay kalabasan ni ani class, natong may no ni. This is net torque. So what would be the what would be the output of this, or unsay value ni ini nga mogawas, mo na siya atong net torque, and that is also, or that would be our answer. So again, unsa may mga force nga nag-interact nato? We have 3. We have 30 newtons, we have 10 newtons, and we have 25 newtons. Class, for the 30 newtons, unsa man ni siya? Is it included in our analysis? Is this included to our moment along O or not? Sige daw. Ha? Not, nga naman. Clockwise. Or napagi pinaka, paano nga reason, nga din ni pwede ang 30 newtons. Tungod kay, usara. Tungod kay, dili perpendicular, napagi duol. Tungod kay, yes, may gid siya, igo gid siya sa axis. Diba, ingon ko kung ang direction sa force nimo kay along gid siya, may igo gid sa axis. Wala gid na torque or moment. So, mo na siya pinakaduol nga reason nga hindi na natin i-considered ang 30 newtons kay. Again, dirita, focus ta sa O ha, kaning O nga axis. So, wala na ni si 30 newtons. Ang nabili na lang kay si 25 og si 10 newton. So, unsay buhaton nato, let's say mag-start ni 25. Unsay buhaton nato ni 25? I-resolve. So, we have here natay component dili. Unsa man siya? This is equal to this. So, let's say this is 25. Largo na ni ha? Unsa man siya? Is it cosine or sine? Cosine. So, actually, ang triangle ni ini kay nagbaliktad ni siya. Actually, pwede man opposite sa inyong triangle. This is 30 also. So, since adjacent man sila, so this is 25 cosine 30 degrees. Class, ang iyang component dire, ma-appel ba na ito calculate? Dili. Sa torque. Dili, kaya ano, niigo naman siya. So, meaning, kanira gad ang iyang perpendicular. So, you just write here, 25 cosine 30, and then what else? Iyahang moment, ano man? Moment arm. Pila may value sa iyang moment arm, class? Okay, 2 meters. So, put here 2. Then, another one. I-consider din nato yung rotation. Is it clockwise or counterclockwise? Sige daw. Pangadto man siya. Pangadto. Unsa may direction na ini kung pangadto? Ha? Counter. So, madto siya. Meaning, negative ni. Kaya nga naman, i-consider mo nga positive kung clockwise. How about for 10 newtons? Diba, since naka-angle siya, we need to resolve the force along the perpendicular. Kani siya. So this is 20. So therefore this is not 20, that is 10. So kani siya, that is this is 10. Then cosine or sine? Okay, sine 20. And what is the direction? Is it kanang counterclockwise or clockwise? Counter or clockwise? Pangadto man siya. Okay, this is clockwise. Kaya naraman imong axis sa O. Di ba? Mga to siya. So therefore, this is clockwise. So that is plus 10, then sine of 20. And what is the moment arm? Is it 2? Kung sa may distance niya from point O. Naman siya diri. So pila naman? 4? 4. So that is 4. That is equal to the summation of moment O, or the net torque. Okay, so more na siya class. Then perform the operation. Negative 25. We have cosine of 30 multiplied by 2. Then plus 10. Then sine of 20 multiplied by 4. Now our answer is negative. So we have here summation of moment along O is approximately equal to negative 29.62 Newton meter. Okay, how are we going to interpret this? Unsay pasabot class sa negative? Okay, so naingon, meaning kung nag-assume ta nga positive value is clockwise, if we arrive a negative value, it means that this is counterclockwise or CC, counterclockwise. So you can just rewrite your answer in this way, approximately positive 29.62, so this is 62 Newton meter, and then you just write CC, or this is counterclockwise. Okay, nakuha ra class? Na question? Wala ra. So let's solve for the other axis. Axis na punta ni C. I mean, ato sa ni-erase kaning uban diri. Okay, for axis C, na-change na ang ato ang itong axis. So here axis C. Same ra gyapon, net torque lang gihapon. So here required is the summation moment along C, or this is the net moment or net torque. So mara gihapon, solution nimo class, summation moment na lang. Summation moment C, we don't know, so positive lang if it rotates clockwise. So here class, unsa man nga force niini ang dili na ma-applied sa ato ang axis at point C. Unsa man, is it the 30 newtons, 25 or 10? Okay, 25. Again, ganun 25, hinigo na mangod siya sa axis nato nga C. Okay, so wala na 25. Only 30 and 10. So for 30, since nakakuha naman siya, naka-angle, so ato i-resolve. So mo na siya ang ihang perpendicular side. So this is 30. Unsa man, cosine or sine? Is it cosine or sine? Okay, so this is sine. But actually, pasalamat mo kung 45, bahalag ma-cosine na og ma-sine. Di mo marong kay equivalent ra man gud ang cosine of sine. Okay, so right here 30 sine 45, what is its moment arm sa atong 30 Newton nga force with respect to our axis C? Unsa man? 2. So this is 2 meters. Again, after that, imo i-verify unsay direction sa ato ang force nga 30 Newton. Is it clockwise or counterclockwise? Nag-ingon naman na siya. Counter. Since padong man siya downward, so mura na siya pa-cause og rotation pangadto since naraman ato ang axis. So therefore that is negative kay counterclockwise man. How about for 10 newtons? Again, ato na po i-resolve. So this is 10 newtons and this is the perpendicular force. So we have here 10 sine naman, di ba? Previously. 10 sine 20. So we are going to write unsa man class, is it positive or negative? Unsa man pangadto man siya. Is it clockwise or counterclockwise? Okay, clockwise. Since naraman atong axis letter C, so paadto siya pa clockwise. So that is positive 10 sine 20 degrees and its moment arm is it 4 or 2? Okay, 2. So 2 meters, that is equal to our summation of moment or the net torque at axis C. Okay, if you have calculator, so simplify. So that is approximately equal to negative 30 sine 45, then multiplied by 2, then plus 10, then sine plus 10 sine 20 multiplied by 2. The answer is approximately negative, so this is approximately negative 35.59 Newton meter. So again, if it is negative, so therefore you can just rewrite this as 35.59 Newton meter, and then since ang atong convention is positive siya kung clockwise, so therefore if this is negative, so we can say this is counter clockwise. Okay, you can have this answer, but mas better ni siya kaning nanay direction. Kay ingon man day siya class. So again, dili ko mo accept ni day negative. Dapat imagine klaruhon class. Mas mo accept ko ni kay it states here that magnitude and direction. Actually, this is for torque class since cross product man ni ha. Cross product na siya. Since ingon diri nga kanang kuan, kaning counterclockwise, this is just the direction of the rotation. Actually, in reality class, gamit ka og right hand rule. Okay, so imong right hand rule, makita mas siguro akong kuan. Ako i-share akong kuan video. So if maklaro ninyo ang kamot, so kani siya mo ni ato ang kuan. This is my right hand, kani siya. So if ever kani, so kani, let's say kani siya kay kanang kuan counterclockwise ni if magkumo ka, so this is counterclockwise ana. So ang imong thumb mo ni siya mag-represent sa imong direction. So since kay kani siya nag-rotate mo ni siya counterclockwise sa ang kamot, so kani siya meaning ang direction sa imong resulting moment is upward. So based atong problem is that is away from the page. So if kani siya kay clockwise, so meaning ana ka paubos na pug ko. So mura bag pa kuan paubos pa ana. Kay pa clockwise naman di ba ang kamot nako pag magkumo ko clockwise na siya. So meaning, ang direction sa atong moment, ang resulting vector niya is pa-downward. Kaya ang akong thumb, nag-downward naman. So you can use your right hand in order to determine kung unsay direction sa imong torque vector. So class, nako ara? Nakuha ra? Nakuha ra. So you can use your you can use your right hand. So naklaro ra class? Balik ta. Okay. So maklaro pa rin yung class ang presentation. Okay. So do you have any question regarding our problem 1? My question? So wala na. So please indicate class if i-required nyo mga direction. This is since this is counterclockwise, so by using your right hand rule, counterclockwise is away from the page. So that is away from the page. Again, if it is clockwise, so that is towards the page. Kay paubos man marabag thumbs down ba? Boo, thumbs down nana. So that is towards the page. If it is a thumbs up, so that is away from the page. Okay, so let's proceed to our final sample problem. So here, actually, ang other nga mga other courses or other nga mga kanang courses ang civil ug ang siguro ang uban siguro wala pa naka sa ilahang first long exam. Kay atong first long exam class actually na nagi-question wala sa lang ta mo gipatay kay wala man ta nahuman. So kani siya nalabot ni Ari. So if swerte mo karon kay naa mo dere, so na may idea sa pag-answer kay included ni siya sa inyong first long exam. Kani siya nga type of problem. So here it states that a uniform ladder 10 meters long, so kani siya kaning ladder, and weighing 5 newtons rest against a frictionless vertical wall. So our vertical wall here is frictionless, meaning walay resisting force. So ang ladder niini walay nagpugong niya, kay frictionless man. Then if the ladder is just on the verge of slipping when it makes a 50-degree angle with the ground, find the coefficient of static friction between the ladder and the ground. Of course, ang kaning static friction nato wala ni sa vertical nga wall. Ngano man, frictionless naman ni. So nagin siya diri dapit. So natay gitawag diri nga mu s. Okay, natay mu s dira. So in order to solve for this class, so naman tay angle nga 50 degrees. So what we're going to do here is we are going to apply static analysis. Class, nganong static analysis man na may idea unsa inyo makita diri nga clue sa atong problem? Nabo may idea nganong static analysis tong gamiton ani? Nganong static analysis man unsa may clue nga atong makita sa problem why we are going to use static analysis? Ha? Saman. Kani siya. Kani if the ladder is just on the verge of sleeping. Diba? Na-get niyo ang idea? Diba? Hapit pa lang daw siya. Hapit na jud. Mani pasabot ba? Hapit na ni ma-slide. Do you get the idea, class? Okay. So hapit. Okay. Hapit lang daw ko no. Ang akong gigamit ari is or ang atong gigamit is mu s. So for mu s gali for static friction naghunong ni. If mu k again for kinetic friction naglihok. So kani on the verge pamangkid of sleeping. Muslip pa man, meaning nag-steady pa ni siya. Hapit pa lang gid din siya ma-slide. So here, requirements, we are going to find mu s, or the coefficient of friction. So solution, again, since we're dealing with static analysis, mas better good nga na kay FBD. So unsa may class, unsa may object nga present sa atong system? FBD. Unsa man class? Ang ladder. Okay, so you need to draw the ladder. So draw the ladder. Gana ang ladder class. Okay, nay angle are nga 50 degrees. Unsa may force nga nag-interact niya? The first one is kay bawta sa iyahang weight. Asa man ang weight class? What do you think? Asa ang weight mo act? Taas man ning ladder, asa man gid ang concentrated nga weight mahimutang? Naasa unsa man? Do you think sa ubos? Asa man niya center of gravity? Nasa tunga. Tunga gyud, di ba? Tao sa may center of gravity mo tunga gyud. So man dra mo weight. Kung rectangle, di ba? Dira po iya weight tunga. So for a certain rod, dira gyud tunga. Do you get the point? Di ba? Ang center of gravity sa ato ang kuan, sa ato ang ladder. So nakuha ra class? Okay. So nag-act na siya sa kuan, sa center. So diri ang atong weight, which is let's just say this is W, or the weight of our ladder. And then what else? Unsa pa may force nga nag-interact sa ato ang kuan class? Sa ato ang ladder. Di ba? Since it rests on the wall. So therefore, ang wall kay mi unsa man? Okay, normal force. So ang normal force is towards this, di ba? Or you can just say here this is N. But actually, nabmagutay N diri nga another representation. So you can label this one as N. For sa ako class, mag-label na lang ko og lain nga variable kay para di siya mabalik-balik. Kaya po kay normal force obos good. So I can just say this is the reaction force of the wall, R. Ay kalibog ha? Actually this by definition normal force gyapon na siya. Pero ako lang gi-represent as R. Or I can say that the normal force here is just the reaction of the vertical wall. What else class? Unsa pa may nag-interact sa ladder class? Sa ubos, unsa may naaari? Naatay? Unsa man? Static friction. Diba natay static friction are? So we have here, diba unsa may possibility nga kanang may tabo sa ladder, diba padungad to? Diba mo ana gini ang ladder, maslide di padungad to. So therefore ang direction sa atong static friction is padungad to. Okay, sa left, sa right. Kay of course, may mupugong. So we have here F, then Fs. Okay. Then of course natay unsa man? Natay gitawag diri nga since rest man siya sa diri sa vertical wall, di ba? Horizontal sa floor. Unsa pa may laing may act? Ang gitawag nga unsa man class? Okay, normal force na po. Basta ragig na yung mga surfaces class na ganay normal force. So this is the normal force. N. Okay. Take note kaning kung gi-arrow class, mo siya direction nga mo slide ang ladder. So ato na erase. Kay nakaibaw naman ta sa direction sa ato ang friction. Okay, what is the next step that we are going to do here? Unsa to unahon class? Unsa mo tong duha class? Kung mag-analyze tag static. Okay, we are going to consider the force and what else? Force lang ba? Ang force ug ang unsa man? Moment, di ba? Okay, force and moment. So let's have first the force. So for the force class, so summation forces along the vertical is equal to 0. Kaya nag-steady pa man gini siya. So consider that positive if it points upward. Okay, class na ba may klase? Na may klase? What time? 10:30? Okay, since mo naman ang last, so sadly nga nila kita kutog. Asa pa sa tong ko ano? So mag-record lang siguro ko ani para makakuha na gid mo. Maka-take na mo sa exam kay basig mabiyaan mo sa others ba. Okay. So continue tanini. So we have positive if it points upward. So unsa may mga forces nga naa sa vertical class? Una, unsa man? We have the okay. So the normal force. So the normal force is positive kay point upward minus the weight of the ladder is equal to 0. Or I can say that the normal force is just equal to the weight. How about forces along the vertical? So I have here summation of forces along, horizontal is equal to 0. So I can say positive if it points to the right. So unsa man nag-interact na mga forces along the left and right? Unsa man? We have okay. So since si frictional force kay sa right, so I can say Fs minus R is equal to 0. Or I can say frictional force is mu s, then what unsa ko to again for frictional, that is multiplied by the normal force minus r equals to 0. So di ba naa na tay normal force which is equal to weight? Do you agree class? Okay, since our normal force equals to weight, so therefore I can just say here mu s w minus r is equals to 0. Based on this equation class, unsay unknown diri? Unsa may unknown? Class, unsa may unknown ari nga part? Unsay mga unknown or unknown lang? Unsa man class? What else? Unsa man? Unsa pa man? Mu s and then what else? Mu s lang ba? Okay, so wala tay r, di ba? Tubag. Get 1/4. Di ta mo klase. Okay, so we don't have r and we don't have mu s. So we have two unknowns, then usa ra pud to equation. So mao nang importante nga mag-resolve ta og moment. So mao man sa class kay usap pa man na. Mao pa man niya generate na to nga equation. So this is equation 1. So here we all know nga for static analysis we have summation of moment. So asa man ta pwede maka take og moment ni ini class? Actually daghan tay pamaagi kay di ba duha man ang atong access point ani pwede po ta ari sa ubos pwede pa ta sa babaw. But legit ang ubos class nga naman kay maramag naimi pugong dira, then mara siya multiple down mo yana. So legit ang ubos, pwede po ka diri good, pwede mo ka diri. But ang sa babaw mo good, mahita po sa babaw kay it will take you a lot of time para makuha nimo mga unknowns. Kay di ba? Sige daw, babaw ta. Pag babaw nimo, what na si R, kay si R naigo man sa babaw. So ang atong tanggolan ni kay makuha din si R. So dili na lang ta sa ubos. Do you get the idea? Consider natin ang axis O. Do you get the idea, class? Okay. Dili na lang ta sa ubos para makuha din si R. Okay. Take moment. Take the summation of moment along along O is equal to 0. So this time, class, okay, this time gi-0 na nako. Dili na sa previous kay net torque man to. Kani siya kay static analysis man ni. For statics, 0 ang moment. So again, sign convention, take positive if it is clockwise. Okay, here, unsa man para di mo maglibog, ay mo kani siya kay kani siya label ni siyang arrow ani, di ni siya buwan ni siya nag-indicate sa forces, label ni siya sa axis. Okay, unsa may mga forces nga ma-cancel out nga di na nato ma-input diri sa moment along O, unsa man ang based on our FBD, unsa may mawala. Okay, the normal force and the frictional force. So kani sila, kaning FS and then N kay naigo man sa axis, wa na siya. So unsa lay mga forces nga wa naigo, kaning weight and the R. Okay, so since si R kay paana man, so negative siya kay clockwise man siya, di ba class? Counterclockwise. For the weight, unsay direction sa weight, class? Clockwise. So positive si weight. Is weight perpendicular to our axis, class? Ang yan direction, is it perpendicular already or not? Nganong dili man? Perpendicular or dili pa? Take a look at the weight. Nag-ana siya. Asa na atong axis kana. So therefore, he is already, or it is already perpendicular. So just write here W. And how about its moment arm? Do you think 5? Actually, balik ta dire. So dili na ta para maklaro. Nag-ana ang weight, class. So meaning, mo na siya ang ihang R. Okay. So ibuhatan nato. Di na natin i-resolve. I-resolve na ang distance. So since this is 5, did you agree mo ni class nga kaning distance sa ladder sa tunga niya kay 5, di ba? 5. Di ba class? Nasunod ra? Okay. If this is 5, so this is your hypotenuse. If this is 5 and this is 50 degrees, so what is this? Our R is, since R is adjacent to our 50 degrees, so we have 5 cosine of 50 degrees. Diba? Agree ba mo? Agree ba? Okay. Agree. So, you can write here W, then 5 cosine of 50 degrees. Since our reaction R is counterclockwise, so this is minus R, and then what is its moment arm? Di ba ang R kay paana diri? So kani siya nga height, this R, di ba? Kay mo naman yung moment arm, perpendicular man siya ani nga R. Di ba class? Nakuha na gets ra? Okay. So unsa may value sa atong R na ini? 3.21. I mean, sorry. R1 lang ni para yung maglibog R1 and R2. Unsa may R2 diri? Unsa may value sa R2 in terms of the trigonometric identities? Diba makaporma man tag right triangle na pod? Diba right triangle? Then this is 50 and this is R2. Ha? This is 10, diba? 10 na ni. Nga naman. Na naman sa babaw. So R2 is 10 sine 50 degrees. So okay, so 10 sine 50. So we have here minus R, then 10. Okay, 10:30 na. So last na lang gini class. So this is 10 sine 50 degrees. That's equal to 0. Since si R atong ipangita ari, so we can transpose this. Then we now have R is equals to W, then 5 cosine of 50 degrees all over 10 sine of 50 degrees. Diba? Nasunod na class? Sunod na? Okay. So, the next one is, since na naman tayo value sa R, so we can substitute this on equation 1. So we can say that from equation 1, we now have mu s, and then ako lang i-transpose ni si R sa right side class ha, para mapastig na siya. So we now have mu s w is equal to w, which is our R, 5 cosine 50 degrees divided by, this is 10, then sine of 50 degrees. So since W is kanang common on both sides, so makancel out. So what's left is mu s is equal to 5 cosine of 50. So ating erase. So this is 5 cosine 50 all over 10 sine of 50. Or cotangent na siya class. Kay cosine og sine cotangent. That is 5 cosine 50 all over 10 sine of 50. And the final answer is approximately 0.42. Okay, unsa may unit ni class? Unsa unit? Wala, okay. Abi na ko na unit. Since this is a coefficient of static friction, so it is unitless. So therefore, this is our final answer. Approximately 0.42 is the static friction or mu s. So far, na question?